Hello and welcome back to another episode of serde-yaml. It's Byron speaking. And on the previous episode, I realized that actually to do this, I should have a better understanding of the spec, just to learn about the terms used. Because in the moment you deal with serialization, you definitely want to understand what possibilities there are. Because originally it started with the question of, okay, how do I deal with JSON, right? Because JSON should be a valid output for me. I should be able to output JSON like this. I should also be able to deserialize this, but that's obviously not what we are dealing with now. But even for the serializer, we need some sort of notion to say what kind of form we want. Do we want JSON style? Do we want default style or something, or default YAML style? What is that style? How does it work? What terms are used to describe how this is looking like? I have no idea. And in the previous session, that was 1 hour and 5 minutes, I at least finally realized that I have to read the document and also kind of figured out a few things that I'm so far quite confident about. So block scalar style means that, or is the description of the style of a scalar within a block. That's what this means. And the structural style means that we can define collections and mappings using blocks or the block style or the flow style. So basically within a block we can have scalars with these particular two styles. This is what we have here. That's how I see it right now. And I guess in the moment we use open and close, you want to know what we are opening and closing just to understand what is going on. So what I'm just to understand what option we have to use here to serialize this. And for now, I have added a sequence structure style and a mapping structure style just to be able to define how we should serialize mappings and how we should serialize these guys here, or serialize mappings and collections or sequences. And this really, right now I don't actually know how I would do this, but it's at least a start. I think we can still not describe what we want here, because this, we have no way to say, well, the keys should be enclosed in double quotes. I have no idea how to say that, and there are many things missing. But this might clear up once I have read more of the documentation. Okay, and that's because it's kind of a first time, I will do this on camera. I have no idea how it is. It's probably kind of weird to just read it out loud, but maybe it's kind of a reflection style that helps, or a very reflective kind of reading such a document, which might help understanding it, my first time. So let's see how that goes. All right, YAML integrates and builds upon concepts described by C, Java, Perl, Python, Ruby. I'm inclined to say blah, 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 and JSON. The syntax of YAML was motivated by internet mail and remains partially compatible with the standard. I don't know how useful it is if it's just partially compatible. I mean, great, that's where it's coming from. Let's just keep it in mind. Further borrowing from MIME, YAML's top-level production is a stream of independent documents, ideal for message-based distributed processing systems. Okay, so we have documents, right? And this document stuff is, I think, this is kind of a bit similar to the way you specify. I don't know. Is this kind of similar to the way you specify mine? No, I'm thinking of multi-part documents in HTML, which also supports the notion of document start and end. And I think in YAML, it's kind of, this is a document start and this is document end here, and everything in between is a document. Yeah, so that's how that would look like. As you can see, there's lots of uncommitted stuff here, just because I think I will just keep going until I have something that makes more sense. YAML's indentation-based scoping is similar to Python's without the ambiguities caused by tabs. Spaces only, right? Yeah, this is something interesting. I think indent should be more like indent by, huh? Should be private, I guess. But then I can't create the structure manually anymore. I think considering it's, yeah, and that's open too. So this is where I'm reading. This is where I can just jump around to look ahead. So the indentation, is it supposed to be only spaces? Oh, ident. Indent, sorry. Indentation spaces. In YAML block styles, structures determined by indentation. In general, indentation is defined as 0 or more space characters at the start of the line. To maintain portability, tab characters must not be used in indentation. Okay, since different systems create tabs differently, note that most modern editors may be configured so that pressing tab results in insertion of the appropriate number of spaces. The amount of indentation is a presentation detail must not be used to convey content information. All right, so that means a block, yeah. So basically, I think I don't want to expose the indentation character here. I think I want to have something like in ident by. So let's have a constant here that says ident, which is a character which shall be a space. The only allowed indentation character. And then we might have an, actually it's indent, damn it, I don't get this right, indent. Then we might have an indent by, which is, well, probably a U size that specifies the amount of spaces one indentation level will assume. Spaces per level, spaces per indentation level. Let's be very specific about this, because if I hate something, then it's variable names that don't help you. And then I'd rather have it as long as this, including some sort of more or less decent documentation. We'll assume. So ident. So let's keep this thing compiling, right? Previously it did indeed compile spaces per indentation level. The good thing is that now I do not need that anymore, so I can kick it for now, and then we might have to edit as well. Damn it. I'm saying that maybe later we have to re-edit, but you know, once we have to do it, we will do it. Right now there is no need. So yeah, unfortunately all this work is gone again, and it's, you know, it's like the third time I'm doing this. The second time I'm removing it. And yeah, this is annoying. For refactoring, this is totally annoying. I don't like, this is really a property of Rust I totally hate, because this kind of stuff that can easily be elided is, you know, forces you to do this back and forth and waste your time just because they don't, you know, they don't want to add this automation, even though it's totally possible to do this correctly. Damn it. So that's one thing that is bloody annoying. But I will just live with it. There are bigger fish to fry here, that's for sure. But I think it's a good sign that I start bitching about Rust a bit, because this might mean that I start to kind of know it well enough to, well, know things I don't like so much. But that's, you know, the case in every language there is in this world. So is there an A left here somewhere? It is. There we go. And that should be it. Good. Indent. And where do we use it? Here we just give it the indent. Yeah, I think we also want to adjust the signature to take characters instead. Or maybe not to take the indent at all, it can just use the global. Like this, huh? Because it's not free anymore. There's no need for it to be free. So this call here is always current indent. I think we want to multiply this by self opts spaces per indentation level. For now, I just make it work. Let's see what kind of type current index is. User is good, that's compatible, so we can just keep going with that. Yeah. And spaces per indentation level we use where? Here. And here it's by default 2. So that is that. So with a little bit of luck, that could actually compile. Did I fix this one up? No. Write all. Yeah, is there something like write char or something? Or do I have to put it into a temporary array? I will if I have to. Oh, actually we have write here. Takes a buff, write fmt. I could use write fmt, but I guess, you know what? I guess making this a buff or a static U8 will be preferred. Yeah, because that will naturally be compatible. Write all, and we will write indent. There we go. So that should work, right? Because this just wants to have a U8 slice. And here we have a wonderful U8 slice. I'm not sure if I have to specify static here, but I guess I will find out anytime now. Wow, that actually did something. I'm amazed. And look, it even, you know, used this. So if I put this to 4, this should look a bit different. And it does. Awesome. So spaces are now enforced. Awesome. This is what I wanted. See, just reading the first line kind of helped us to make it better. The type stuff I can remove. So the right side is the one we can jump in, and this is the one we are reading. Okay, without ambiguities, indentation. Indented blocks facilitate easy inspection of the data structure. YAML's literal style leverages this by enabling formatted text to be cleanly mixed within an indented structure without troublesome escaping. Okay. YAML also allows the use of traditional indicator-based scoping similar to JSON and Perl. Such flow content can be freely nested inside blocks. So we can basically decide what kind of flow style we want to have in each block, I guess. So now I just want to click this link. Here, where is it? Flow content. Flow styles. Yeah, okay, I've been here multiple times. YAML's double-quoted style uses familiar C-style escape sequences to enable ASCII encoding of non-printable or 8-bit characters such as non-printable 16-bit Unicode and 32-bit ISO blah blah characters are supported with escape sequences such as U blah 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 and okay. So I guess this is something I really want to take care of. I mean, this is very, very important, this Unicode-ish support. Let's make a... Yeah, I think this is something that we will handle anyway in the moment we serialize strings and kind of test this explicitly. And yeah, I think I won't forget that anyway, so I won't note it down. So motivated by HTML's end-of-line normalization, YAML's line folding employs an intuitive method of handling line breaks. I think a single line break is folded into a single space, while empty lines are interpreted as line break characters. This technique allows for paragraphs to be word wrapped without affecting the canonical form of the scalar content. Okay, let's just jump there. Line folding, I know about that. That is a space character. The serializer is going to be quite a biggie, I think, once I'm done with that. It's not at all as easy as I was thinking it is. But hey, I think it's a good starting point. Anyway. Can I jump there? I can jump there. Okay, so that's the kind of encoding. We can have hex digits, U4 and U8, 16-bit and 32-bit. All in hex. Yeah, hex digit. Okay, U and U. I see. And special escape characters here. I see. Kind of. Okay. Let's keep going. Modify, okay, that's the end of line break. Let's have a look at this. Line feed, carriage return. Okay, here we go with the canonical form. YAML supports the need for scalar equality by requiring that every scalar tag must specify a mechanism for producing a canonical form. Ah, this form is a Unicode character string which also presents the same content and can be used for equality testing. I think the canonical stuff is also in PyYAML, which then causes it to be printed like this, or output like this, or presented like this. While this requirement is stronger than a well-defined equality operator, it has other uses such as production of digital signatures. All right. Don't know. YAML's core type system is based on the requirements of agile languages such as Perl, Python, and Ruby. YAML directly supports both collections, mapping and sequences, and scalars. Support for these common types enable programmers to use their language's native data structures for YAML manipulation instead of requiring a special document object model. Yeah. So the DOM basically is represented by a custom value enumeration in Rust, usually. So JSON shows how this is done. It's just a nested enumeration. Like XML's SOAP, YAML supports serializing a graph of native data structures through an aliasing mechanism. Yeah, so right now I wouldn't support this, at least not for serialization, because we would have to build our own tree beforehand, which right now we just don't do. We just would output the stuff directly, I guess. Also, like SOAP of YAML, YAML provides for application-defined types. Okay, I know how this works. This allows YAML to represent rich data structures required for modern distributed computing. I'm just laughing because even though all this is supported, it's probably, nothing you would want to send around, because then you can also go binary and use Captain Proto or something and have far far better performance. But who knows? YAML provides globally unique type names using a namespace mechanism inspired by Java's DNS-based package naming conventions and XML's URI-based namespace. In addition, YAML allows for private types specific to a single application. Yeah, that's pretty cool. And this is also something we should somehow, possibly support. Possibly. Think about it. Just think about it. YAML was designed to support incremental interfaces that include both input, get next event, and output, send next event, one pass interfaces. Together, these enable YAML to support the processing of large documents, for instance, transaction logs or continuous streams. Okay, so this means we don't have to build a data structure in memory. We can also just do it on a callback basis, which is what we have right now, right? So this is kind of what I would aim for in the first version. So something like aliasing is kind of unsupported by us, at least for serialization, and deserialization is something we might add as well. I mean, should be possible, but I don't know how that would work. I leave that for some later version, because even I myself do not need that right now. And yeah. Relation to JSON. Both JSON and YAML aim to be human-readable data interchange formats. However, JSON and YAML have different priorities. JSON's foremost design goal is simplicity and universality. Thus, JSON is trivial to generate and parse at the cost of reduced human readability. That's true. It also uses a lowest common denominator information model, ensuring any JSON data can easily be processed by any modern programming environment. In contrast, YAML's foremost design goals are human readability and support for serialization arbitrary native data structures. Thus, YAML allows for extremely readable files, but is more complex to generate and parse. In addition, YAML ventures beyond the lowest common denominator, data types requiring more complex processing when crossing between different programming environments. YAML can therefore be viewed as a natural superset of JSON, offering improved human readability and a more complete information model. This is also the case in practice. Every JSON file is also valid YAML. Yeah, so this is what I want to get at as well. This makes it easy to migrate from JSON to YAML when additional features are required. JSON RFC blah blah requires that mapping keys merely should be unique, while YAML insists they must be. Technically, YAML therefore complies with the JSON spec, choosing to treat duplicates as an error. Yeah, so I think this is something that yeah, I don't know how that would work in our case. We probably would just override it if there are multiple calls, would we? So what visit map element? Okay, that's a serialization mode here. I think we just serialize whatever there is, and keys cannot be duplicate. So when serializing, there is no problem. And deserializing something, this is a bit different. And there, this map thingy. Yeah. I don't know how that works anyway. But here it's kind of decided how it deals with duplicates. I don't know. It doesn't... I don't know. Whatever. Yeah. Let's not venture too far. So, it may be useful to define an intermediate format between YAML and JSON. Such a format would be trivial to parse, but not very human readable like JSON. At the same time, it would allow for serializing arbitrary native data structures like YAML. Such a format might also serve as YAML's canonical format. Defining such a JSON format, WYSIN format, WYSIN is a serialized object notation, can be done either by enhancing the JSON specification or by restricting the YAML specification. Such a definition is beyond the scope of this specification. Yeah, I'm very happy about that. Let's keep it simple, huh? So relation to XML. Newcomers to YAML often search for its correlation to XML, extensible markup language. Although the two languages may actually compete in several application domains, there is no direct correlation between them. YAML is primarily a data serialization language. XML was designed to be backwards compatible with the standard generalized markup language, which was designed to support structured documentation. XML therefore had many design constraints placed on it that YAML does not share. XML is a pioneer in many domains. YAML is the result of lessons learned from XML and other technologies. It should be mentioned that there are ongoing efforts to define standard XML YAML mappings. This generally requires that a subset of each language be used. For more information on using both XML and YAML, please visit yaml.org XML. All right. I will not do this. So, terminology. The specification uses keywords based on RFC to indicate the requirement, and in particular the following words are used to describe the actions of a YAML processor. May. The word may or the adjective optional mean that conforming YAML processors are permitted to but need not behave as described. Should. The word should or adjective recommended means that there could be reasons for YAML processors to deviate from the behavior described, that such deviation could hurt interoperability and should therefore be advertised with appropriate notice. Okay, so this is something you should probably keep track of as well. So in the moment we deviate or do something that is recommended in a different way, we will keep track of that. So that's important. Let's note that down. Limitations. I don't know. Is this? Oh, that's serde here. No, wait, serde-yaml. Actually, this is wrong. Build instructions. This is old. Deviations from the spec. An exhaustive list of list of I don't know, features, things, issues, items of items showing where we deviate from, where this implementation deviates from the recommendations of the spec. Let's just link it up here, YAML spec. It's all the cases when we, well, let's try not to forget about this. That's all. Right now, we do not really do anything, so no need. Must. The word must, or the term required, or shall. Okay, shall. Important. I kind of interpreted shall as should. Mean that the behavior described is an absolute requirement for the specification. The rest of this document is arranged as follows. Chapter 2 provides a short preview of the main YAML features. Chapter 3 describes the YAML information model and the processes for converting from and to this model and the YAML text format. The bulk of the document, chapter 4 through 9, formally define this text format. Finally, chapter 10 recommends basic YAML schemas. I think chapter 10 I might have read already, even though I will obviously read it again once I have digested the entire document. Okay, the preview is actually an interesting part because it kind of is a high-level preview with actual examples. And what I would find very interesting is actually if we would be able to serialize the entire, all the examples here without the comments. We can't serialize comments usually because that requires metadata of some kind that we do not have the facilities for, unfortunately, unless we do macroing and compiler plugins or code generation that I do not want. But anyway, it would be great if we could kind of serialize each example here just to show that we can do it. And I guess there's something we might want to start off with Python and then kind of translate this translate this into data structures that we add to that we add to our test cases, to our Rust test cases. So sequence of scalars. So this is something we already generate, kind of. That's this one where you say default flow style false, right? So this is this. And I think all we have to do is let's use it like this. Let's just add these here, because I want to definitely deserialize them. If I serialize them that way, I think I also want to serialize them that way just to show it, right? This is kind of part of my test suite, so it's work I would really like to do here. Example 2.1, let's use underscores for everything. And yeah, no further description needed. We just want to dump this as it is. So we have Mark McGuire. And I do hope that Python will always allow us to generate this exact output. And I think it will be possible, because that doesn't look too complicated. Let's put this here. Make it a bit more readable. Blah, blah, blah. So we have to kind of approach it from multiple vectors. So that is that. So if you make test here, we will get this additional data structure. So that's how that looks like. In Python, this already works nicely. And here, yeah, I could have a data structure for every single one of these, or just a hash map. I wonder if there is a hash macro by now that I can use. Oh no, wait, I would just want to have a list of, no, a vector of strings. That's all I need here. And I think that's already serializable. So here is the test. So we can have another test here. Let's add, I will remove these printings here at some point. So that's example 2.1. And the data shall be, a slice. I hope string slices are supported. Yeah, let's see how that goes. Let's just define the structure as we think it should work. We should be able to copy it from Python here. It looks very similar, at least. Like this. Yeah, so this will give us a slice, not an array. We would have an array like this, but like that we have a slice, which is a good thing. That's the data. We want to serialize this into a string. I think we can just put it like this, theoretically. And that should be example 2.1. Right? So let's see. Cargo, make test. Let's be sure we use make test all the time. is a semicolon missing. So we are still kind of doing bulk work. Look at that. So we managed to serialize it, but we couldn't really do it. But that's expected. We have to use options here to possibly to kind of make it work out of the box like this. I don't know how we want to do this, but you know, it's good to have this test anyway. So let's add some tests. That's what I'm saying. The bad thing is that we might end up with a lot of tests here, and you know, let's just see. We will see how that goes, because I think I'm not able to run individual tests here, unfortunately. Yeah, but what I like is that the data and stuff is kind of separated, so that we have a generator for the data here as bases, and yeah, possibly custom data structures that are defined elsewhere and implemented elsewhere. Yeah, like this. Let's do it like that. Okay, so the next one. The next one is this one. Okay, also we might want to read a little bit of this. YAML's block collections use annotation for scope and begin. So block collections, we had this before. And begin each entry on its own line. Block sequences indicate each entry with a dash and space, and mappings use a colon and space. To mark each key value pair, comments begin with an octotorf, what? Also called a hash, sharp, pound, or number sign. Octotorf, wow, I've never heard that before. Yeah, the cool thing is I can actually just take this and put it there. I don't have to serialize it. I can, but I don't have to. That's a cool thing. Like that. And I guess it wants to have a new line, possibly. Yeah, the only shitty thing is that indentation goes totally crazy. So let's assign it. And then we write down the data. Example 2.2. Example 2.2, that's just state ID. Like that. And we are done. And the flow style, yeah, is something we don't have here because we don't even make the YAML dump call. Okay, so that's how that could look like, I guess. And now, not to forget, in the test case, we want to add example 2.2. And then just say, well, yeah. Wait a second, I do not get the, yeah, damn it. So here I need an own data structure because that's integers and floats mixed. So I can't put this into a single hash map, unfortunately. I would need a YAML value that I do not have right now. Or yeah, in the meanwhile, I need a structure to do that. Probably for many of the examples, I need structures. Yeah, unfortunately, I cannot put comments in there. That's impossible. So I guess I want to change this thing around to use actual data. So D is audit dict. Then we go ahead with individual tuples, saying HR 65, ABW 0.278, RBI as 147. like this. And here we go. And now, not to forget YAML dump. I wonder if I have to specify the flow type. I don't think so. I think this will work just fine. Let's generate this. Oh, something is wrong here. True. It's a tuple, after all. Okay, how do you like this? Oh, see, it wants to have the flow type. Interesting. Pretty options. Let's call it ops pretty. And let's take it here. Ops pretty. And like this. That's a bit better. All right. Now that looks the way it should look like. HR, average, and RBI. Yeah, so unfortunately I will need a custom data structure now. Example 2.2, which is HR U32, whatever that means. Home runs. Okay, home runs, that means batting average is a F32. And then we have RBI, which is once again a U32. And this is something we would now expect to show up in our fixed data so that we can pull it in. I don't know to what extent. Yeah, the structs mod. I just import everything. Good, so that should be fine. Pub. Oh yeah, I want to make these pub as well. And I think I also want to implement the default for it to just be what the tutorial says. Impl default for example 2.2. And fn default returns, we know that this works, self. Example 2.2 shall return HR 65, oops. Average 0.278. Let's see if the position works correctly here when serializing this. RBI 147. That should do, possibly. And then when we serialize it, it obviously works the way it's expected. All right, that's nice, I think. Yep. So all we have to do in this example is get a data, let d be this, structs that, and then we have our comparison. I'm not sure if I want to add this here. Maybe I don't want to print this until I actually handle these, because I guess re-adding this is simple enough. So let's not do this. Let's just have the assertions and make sure they fail, which is the simple part. Like that. Okay, cool. So that's example 2.2 in all the ways possible. Should now only see one printing here. Yeah, that's good. Looks good. So, more examples. It's mainly grunt work here, but hey, what can I do? So 2, 3. Yeah, let's also. Is this being documented then? Are the integration tests documented? Oh, sorry, that's the test cargo doc. Open. Do we have tests? Doesn't look like it. No. Makes sense, kind of. But hey. So yeah, there's no need to add the documentation here. We might want to add the documentation here. Just for completeness. So now 3, 2, 3. So that's a list, a dict with lists built in there. Let's put it down. That's 2, 3. The data is, once again, an ordered dict. But this time we have American and national. And then there is a list of stuff. National, a list of things. Oh, and that goes away. So American shall be Boston Red Sox. It's kind of annoying to put that down, but hey, what can I do? It's something. And having a good test suite is really half the thing that makes this work eventually. So yes, it's time that needs to be invested. I don't think there's a way around that, and I don't feel good if I would find a way around that, to be honest. It's just the tip of the iceberg of test cases that will be needed to get this to work. That's how I feel about it, at least. 2, 3, so that will be dumped now. So on the inside, yeah, I think, yeah, let's do this. No, I didn't mean that. So here, I think we have to do the same thing. We need a new structure with a default implementation. So I guess we would be good with something like this. Example 2, 3. There we have American and national. I could even, no, it's not an enum, it's a struct, because it has both values here. So it's a vec of strings. I could even make it static strings if I would like. Let's make it static strings, because it's gonna be static strings, right? Yeah, right. Yeah, I think so. Like that, like that. I hope they live long enough, but they should. So impl default, for example 2, 3. There we go. Fn default, return self. I totally like that this works. And then it's example 2, 3 with American, and it should be possible to use the vec notation here. Oh, we could actually also, we don't need a vec, huh? We could also use slices with static lifetimes. We could, but let's try vec here. Why not? Why not? That should work as well. So, and now I can again just copy these values from here, can I? Totally so. La la la. And national shall be a vec of these buggers. Oops. Like that. Oh. Deserialize is not implemented for type string slice. Interesting. So it appears to require a string instead. Kind of makes sense. So do I need deserialize? Maybe not. Yeah, so maybe I don't need it. Let's not use it for now, just to get this to compile right away. All right. And now I have to put in the example here, which should be relatively similar, right? I might have a macro for this at some point because it's kind of the same all the time. Yeah, eventually. Oops, see, there's the first copy paste bug. And now this should still work. Oh, should have a camel case name. Yeah, how do I do it with numbers then? Yeah, let's just disable one non-camel case, huh? Allow non-camel case. Like this. So that should be a bit better. Ah, no. Make tests. Yeah, I might have more warnings than I actually need. Constant item is never used, list one default. That's true. Let's add it. So that's kind of the high level cases that I made up myself. So that's the default data that we want to serialize. We want to serialize it somehow differently with options, obviously. And this should be easy to use as well. So as I said, I might have some constructors that provide useful defaults. Data one default. That's supposed to be what again? No, not here. Here, data one default JSON. That one. Okay, cool. So now we have used this, and the last thing we didn't use is the list one default. That's also one of ours, right? And we that's kind of the same thing as the example 2.1. Pretty much so, except that we have mixed types here. Yeah. So I'm not sure. I'm not sure how mixed types would work in a list for us. I have no idea how such a document would work, to be honest. If it's, it's mixed types, so that's only possible with we can't serialize this. I mean, this is what we can serialize in a structure, but this here, we can't serialize in, this is also something we can serialize in a vector, that works. But this one we cannot serialize in a vector. Could be a tuple though. Huh. Interesting. I have no idea. how that would work and if serialize is implemented for tuple types. It might be. For a vector of type T, optional T's. Oh look, we have it for tuples. That's cool. Yeah, so that is going to be a tuple type then. Awesome. So let's try that. Yeah. Let's try to serialize a tuple into this. Sir, let's call it Sir only. Sir JSON, because it's kind of clear what we are doing here. Serde-yaml. And here we say Sir list tuple. Sir tuple. And this is a tuple of a string and 5 and 3.2. Let's call it U32 and F32. Let's just be precise about this. This is something we should easily be deserializing, and now we can use this data here and have one warning less. Like this, third tuple. Yeah, that could possibly work. Let's try it. Okay. Method is never used into inner block scalar, never used, flow never used. Yeah. So that's something that is indeed true, but the rest seems to be fine now. Except that everything is failing, obviously. But that's okay for now. Good. We are nearly at an hour. And I think let's look at this. Whoa. So that's quite some grunt work. But I want to have this in my test suite. And it's not too much after all. I mean, we just have to go through with this, I think, another hour, and we might be done. That's the last one we have. And we will continue with this. I think this will take like 2 more sessions at max, but it has to be done. And then at least, you know, we're going somewhere. We're going somewhere, and I feel more confident to have a complete understanding of what YAML is supposed to be. So thanks for watching, and have a great day.